Okay. Hello, everyone. Good evening. And today I'm going to uh, give you a demonstration of how to use machine learning for predicting different types of exercises uh, based on certain parameters like obesity, level, uh, BMI rate, etc. of an individual. So, without any further delay, let's go to coding. I hope uh, everyone can see my screen now. So what I'm going to do, first I'm going to show you the data set that I'll be working on. Uh, this is the data set that will be used to train the model uh, that is going to predict uh, that is going to predict the recommended exercises to obesity according to the different types of weight, size, BMI, gender, age, etc. to different individuals. So in machine learning, what we do, first we train an algorithm uh, with a specific set of data, and after the training is over, we then uh, test the algorithm, how it is performing. The test data that is used is not exposed to the algorithm during training period. And let me show you. So this is the training data that I'm going to use, and it contains these parameters, and this is the target that we are going to predict. This is my test data, and as you can see, the test data also contains these uh, recommended exercises plan. It is because of these uh, exercise recommendation plans, we can uh, measure the performance of our model. Okay, so it is supervised learning, and during training phase, the model is trained by minimizing prediction error. And once the training is over, in the test phase, the model is tested with a set of data that was not exposed to it during the training phase. And there also we have these labels, class levels, and the predictions are matched against these class levels to see how it is performing. In addition to that, I also have uh, this sample data that I'm not going to expose to it during training phase and testing phase. So I am assuming that this data this sample data that I have, it is completely uh, absent during the training phase and the testing phase. Although the data set is a single data set, this one, and from that I have taken samples and created these three sets. Okay. So these are my samples. So these will be used finally to see how it is performing. So the whole process of training and testing, after that is over, I'm going to use that sample data to see how the model is performing. Okay, so that was the data set. Now we're going to start coding. For that, First, import the necessary libraries. Import NumPy, import pandas, and we're not going to use any kind of visualizations. So I'm not going to use Matplotlib. Apart from that, we are going to use several libraries from the scikit-learn package of scikit-learn package, and I'm going to import those package as and when necessary. So first thing first, we're going to import or read the dataset. So we are going to read the data, read the training data into our data frame so that we can do our necessary computation on it. So let's see, df equals to pd dot read. It is in the CSV format. So read CSV. It is in the current directory, so I don't need to specify the full path. I'm using the relative path of the file. So this is fitness underscore train dot csv. So that's the name of the file. So fitness underscore train dot csv. Okay. So it has been read, and let's see uh, it's how it is. So that's the data set, how it looks like. The first 5 rows: weight, height, BMI, gender, age, BMI case. So these are the independent variables. These are not dependent on anything, and based on that, we're going to predict what kind of exercises an individual should uh, pursue. So if someone is severely thin, okay, very thin, very light exercises. If he is obese, then almost highest level of exercises, and so on and so forth. So these exercise recommendation plans, they include several exercises. For example, suppose for level 1, we will have light walking, morning walk, evening walk, things like that. And for obese people, recommendation plan 6 will have daily exercises of 1 to 2 hours using high intensity level trainings, uh, weight trainings, and so on and so forth. So depending on the uh, different parameters of an individual, we're going to predict, we're going to create a model that is going to predict automatically what the exercise level should be. Okay. Now, if for any machine learning task, the first task uh, involves involve data analysis, but I'm not going to do that today because within 1 hour I cannot show you data analysis and machine learning. It will take more time. I'm just going to show you how to create a model that is going to predict the dependent variable. Now, this data set, let's say, so this is the information about this data set. It contains 4,750 rows, and it contains these are the parameters. These are the independent variables, and we'll have this as our dependent variable or response variable. As you can see, this is an integer discrete quantity. So it is a classification task. Okay. So df log exercise recommendation plan dot value counts. If I do that, you'll see that the, only a few discrete values are there, starting from 1 to up to 7, going up to 7. And that is why it is a supervised classification task. Okay. I'm not going to do any kind of data analysis over here or visualization over here, because that is a separate part of the whole data science process. Uh, I'm just going to do some data pre-processing and then use machine learning to predict. Okay. So why do we need data pre-processing? Because see, these values, they are on the different scale. Okay, let me show you. Okay, so for this weight variable, the mean weight is 79.77, almost 80. Standard deviation is 17.32. Minimum weight that is present in this training data set is 50. Maximum is 109.99, almost 110 kilos. And these are the different quartile values. Now look at this height. Uh, it is in the centimeters, meters, I suppose, and its range is somewhat constrained or somewhat shorter than the range of the weight, uh, as is expected, because here the minimum value is only 1.39 meters, maximum value is 1.97 meters, and so on. The BMI, basal metabolic index, that is in another scale. So here the minimum value is 12.79, maximum value is 33, 34.99, 35 almost. Age, again, it is in another range. It is ranging from 18 to 65. So the numerical variables, they are on different scales, and it is a good practice, and it is a recommended thing that we should scale them so that they all uh, comes under they all come under same scale, so that the algorithm can find out the importance or influence of those variables over the dependent variable, that is recommended exercise recommendation plan. And also, as you can see, this gender column, it contains uh, and BMI case. These two are object columns, means they are string data. And for string data, we'll have two unique values for gender, and for BMI case, we'll have 7. And these are the top values, most frequent values, male and normal. Frequencies of these values are 2385 males are there, and 1410 BMI, normal BMI people are there. These values need to be converted into numbers, into representative numbers, because all machine learning algorithms, they deal with numbers, they deal with vectors, and we have to convert strings to vectors or numbers. So we need to perform two basic types of data conversion. This data set does not contain any null value. As you can see, 4,750 entries are there, and not null count is same for all the columns. So there are no null values. Anyway, you can we can test it also. So df dot is an dot sum no null values. Okay, if it contain null value, then we would have to deal with that. So we are not going to deal with null values, and we are not going to deal with outliers also for this particular data set. Why? Because if we remove outliers here, then the severely obese people, the people who falls under the severely obese category, means this kind of 109.99, very very overweight, those will be removed as outliers, and I don't want that. I want to include them within our exercise regime. So no outlier removal for this data set. So only two types of preprocessing needs to be done before we can apply machine learning algorithm. One is the scale down these numeric columns so that they all come under same column and same scale, and we need to convert these two string columns so that they can be represented as numbers to the machine learning algorithm. But before that, I'm going to, so those are the two types of things we are going to, transformation we are going to perform. But before that, I'm going to separate our independent variables. So these are my independent variables and the dependent variable, this one, the last one. Okay. So for that, let's see, let's say xtr. So for x training, I'm going to say df dot drop, and I'm going to drop this last column, I need to specify whether it's a column or a row. Okay, so df dot drop, and what it's going to do is going to drop this column because I have specified axis equals to 1, so it is going to drop this column from the data set and create a new data set without that column and return that data set. So xtr will contain a data frame, will contain the data without the last column, and the actual data frame df is not going to change. Graph. Okay. Okay. Now let's see xtr something like this. Okay. 4,750 rows with 6 columns, and ytr is this vector. Okay. So it's a series. So now what I'm going to do, I'm going to convert or transform these columns, as I have said. I'm going to use standard scalar, means I'm going to subtract the mean from every value within a column and divide the subtracted result by the standard deviation. So what do I mean by that? For this weight column, every value will be subtracted, or it's the other way around, the mean will be subtracted from every value of the weight column and then will be divided by the standard deviation. This subtraction operation is going to include the sign also. So we are going to have several negative values also. So those are not actual weights of the people, but they are scaled down version of the weight column. Similarly, for height column, we're going to subtract the mean of the height column from every individual value of this column and then divide the result with these standard deviation. And same goes for BMI, same goes for age. Okay, so that's the transformation that we want. For the gender column and the BMI case column, what we're going to do, we're going to use something called label encoding. So for here we have two values and we're going to use male as 0, female as 1, or vice versa. And for BMI case, we have, I guess, 7 values, and these numbers will be converted into, so these are strings, and those strings will be converted into representative numbers. Okay. Now I can do that by taking each column one by one from the data frame. I can do that, and I can also use pandas to perform these operations on the columns of the data frame. But there is another way, better way of doing this thing, and that is by using scikit-learn packages. And there we do it like this. So from sklearn.compose port column transformer. Okay, so what this column transformer does, this class, it is a class that gives us an object that helps us to transform multiple columns or to apply multiple types of operations on different columns on the of the dataset all at once. So we don't need to pick up one by one and make the transformation. Please do remember that we can do this kind of things using pandas also, but it is better to use column transformer or some scikit-learn package uh, because of this thing. We do not need to pick up, and we can apply the transformations all at once. So different transformations will be applied to different sets of columns or individual column all at once, at one go. That is not possible in pandas. Means directly not possible. Certainly you can write your own function to perform that kind of thing. There is another advantage, and that is called it, that is that it is prevents data leak. What do I mean by that? I'm coming to that just after this. So from so we need some other packages also. sklearn.preprocessing port ordinal encoder, and this is for transforming the string data into representative numbers, and standard scalar. This is for normalizing the numeric columns. Okay, so they are imported. Now we need to create an object of the column transformer class, and this constructor, it takes a list of tuples. Okay, a list of tuples, and this list will contain, so it's going to take a list of tuples, and each tuple will contain one transformer object. So first I'm saying the name of the transformer. Let's say scalar, that is scales scales down. The object whose name will be scalar. So standard scalar. You need to create an object, actual object. So I have called this constructor of the standard scalar class, and the column names, the list of names of columns on which this object is going to apply its transformation. So we are going to use numeric column names over here, and for this one, this is going to be my encoder object. So the name I have given to it is encoder, and then I'm going to use ordinal encoder object, and here I need to provide the list of string column names from the dataset. So I can copy and paste these column names from here. So that is the naive approach. There is another better approach. Why it is better? Because there may be number of there may be columns that cannot be uh, copied like this, because a dataset can contain a long list of columns, and manually copying and pasting those column names is not recommended at all. So what I'm going to do, I'm going to create two variables, say numeric column names. Okay, let's give it a shorter name. So num column names, it's going to contain the numeric column names, and obj column names. So this variable is going to contain the names of the string columns. Okay, so for that, I'm going to do it like this: df dot select d type, and I'm going to say include, no, exclude object. So it's going to exclude the string columns and give us a data frame back with only the numeric columns. So at this point, df.select type is going to give us back a data frame. But do we need that? No, we just need the names. So I'm going to say call names. Sorry, typo there. Call names. Okay, and I'm going to do the same thing. So df.select type, and I'm going to include the object columns. Okay, dot columns. All right, now let's see, let's print it out. Columns names, and also let's print out the object column names. Okay, let's see how it is working. Attribute error. Dot select type. T types. An attribute error. Oh, columns. Okay, so as you can see, we have the names of the columns and numeric columns, and we have the names of the uh, object columns. But here I have made another mistake. So I'm not going to use the df as a whole because it is containing the target variable also. So I'm going to use xtr, the data frame xtr that contains only the feature names. xtr. Okay. And now so weight, height, BMI, and age, and I have my object columns gender and BMI case. All right. So now I'm going to supply these two lists into my column transformer object. So here I'm going to say num column names, and I'm going to use obj column names. Done. Okay. Once this object is created, I'm going to use this object to transform our data. And for the training data, I'm going to use it like this. Let's say xtr version 2. So it is the transformed version. Okay, so it is transformed formed like so. So that is the variable. And I'm going to use say ct dot fit transform, and I'm going to supply the xtr data frame. Okay. There is another thing that you should do. Here it is not necessary because I am exhausting all the columns. So either the columns are numerical or object, and I'm not excluding any columns from these two types of transformations. Otherwise, you should uh, use this parameter also, remainder equals to pass through. Okay, so what it's going to do is going to apply the transformations on the specified columns, and if there is any uh, column or columns that are there, is going to just keep them as it is. So these are also needed sometimes. Okay, for example, sometimes you may not uh, want to transform some columns and you want to keep them the way it is, then you should use this, because otherwise by default what it is what it does, it either ignores or drop. So the default setting for this parameter is drop. It's going to remove that column from the result. You should not use that if uh, not explicitly specified. Okay, so what we are going to do, we are going to call the fit underscore transform on this set of data, and it's going to give us the transformed column names, columns. Okay, and what is this? What it does, fit and transform, it first considers or computes what it needs to do, and then it actually transforms the data and give us a new numpy array. So if I run this, let's say xtr underscore transform. If you run this, you'll see that the columns has been transformed and it is an array. It is a numpy nd array. Okay. It's a numpy nd array. And I can supply this numpy nd array to my machine learning algorithm. That's okay. That's fine. If you want to do that, you can do that. But what I want to do, I want to see the data, how it has been transformed. Just for viewing purpose. It has no practical use, just for viewing purpose. For all practical uses, you can use this numpy NDI. So for that, what I'm going to do, I'm going to say XTR transformed. I'm going to create a data frame out of that transform data. So pd dot data frame. So this is the data with which the data frame will be created, and the column names will be from the ct dot get feature names out. So it's going to create new feature names. It's going to create new column names, and I'm going to use that as the data frame column. So XTR transform dot sample, and take 5 samples out of here. So as you can see, this is scalar weight, scalar underscore height, scalar underscore BMI. So what the transformer has done, it has concatenated this string with the name of the column name, and it has included 2 underscores between these two. Okay, so those are my new feature names, and as you can see, we'll have negative heights, we're going to have negative weights, we're going to have negative age, and that's perfectly fine, because these are not uh, these are not exact data, these are representative data, these are scale data. And also we'll have females and males represented at 0 and 1, and for the BMI case, it has been transformed into numbers. Okay. And if you do a describe means basic statistics, then you'll see that the mean of the numeric columns, please ignore these two, because we do not need to compute anything on these two columns. Just see that the mean has become 0 for every column. Okay, and so this is 0, minus 9.2 into 10 to the power minus 16. So it is 0. But for floating point adjustment, Python is not going to show these things as zeros, but they are zeros. Okay, so this quantity is 1.025 into 10 to the power minus 15, and so on and so forth. So the means have become 0. The standard deviation of every column has become 1. And now uh, we can measure their influence, because they are all now in the under the same scale. Okay, so that's all right. Okay, so that's the transformation we're going to apply to our training data. Now let's begin training. So training part, and for that we're going to use the algorithm k nearest neighbor classifier from the scikit-learn package. Ideally, one should use uh, all the available algorithms, okay, all the available algorithms to a data set to find out which one is performing better, because it doesn't matter how expert one is, it is not possible for an individual to predict what algorithm is going to perform well in a data set. Okay, so just viewing the data set, it is not possible to say what algorithm one should use. So it's just a trial and error method. You should use all the algorithms available to you. Okay, almost, or as many as you can. So from sklearn dot neighbors import dot neighbor import k neighbors classifier. K neighbors classifier, K neighbors regressor, and K neighbors transformer. There are three classes, and we are going to use classifier class because our task is of classification type. Classifier. Once imported, I'm going to create a model of this class. I'm going to create an object, and that object is going to be our model. So KNC short form underscore model, that's going to be my variable name, and I'm just going to use K neighbor classifier. And there are a lot of parameters over here. Number of neighbors, you can specify number of neighbors, you can specify the kind of distance measure that is going to be used. I'm not going to define, I'm not going to describe the k neighbors algorithm over here. What I'm going to use, I'm not going to change any of those parameters, any of those hyperparameters, and just use the class as is. Okay. So once I have done that, I'm going to use this class object to train this object with our training data. So our training data is this xtr underscore transformed. I'm going to pass it here, and I also should pass the y training data because it's going to use this data to minimize the error. It's going to use the data to find out it's going to uh, use the xtr underscore transform data to compute error values, and then it's going to compute the it's going to minimize that error value over and over again. It's going to try it in a loop. So that's going to be my fitting purpose. So it has been fit. Okay, the model is trained. Now we need to predict. We need to predict the X-test class and see how the model is doing. And finally, we're going to use the model on the sample data. So let's do that. So for testing purpose, so now I'm going to use the testing. Sorry. So now we're going to test, and for that I'm going to load the test dataset, fitness underscore test. So let's see X test, or let's say test data, test df equals to pd dot read csv, just like before. And name of the file is fitness underscore test, fitness underscore test dot csv. Done. And test underscore df looks something like this. Okay, there are 250 rows and 7 columns. Now we need to separate the parameters from the target variable. So x test equals to test df dot select t types, exclude object, like so. And oh no, select df dot drop, sorry about that, dot drop this column, exercise recommendation plan. Access equals to 1. YTS is going to be test df dot test df and that column. Okay, so now I have my parameter data frame of the test data and also the target test data. Now, before I ask my model to predict anything, I need to perform the same type of transformations that I did on the training set data. Okay, so these transformations need to be performed on the testing set data as well. And here it eliminates the data leak problem, which cannot be performed in pandas, because here what we are going to do, we are going to use this CT object to transform the columns of the test set. I'm not going to fit it anymore. So no computations will be done will be done on the testing set data. Is only the computation that's going to transform the test data is going to be performed. Okay, so let's see. XTS transformed, it's going to be CT dot transform only XTS. Okay, so it's going to transform the test parameters, test data. It's not going to compute any mean or standard deviation. It's not going to decide how many types of string data are there. It's not going to perform any of this. It's just going to use what it has learned learned from the training phase, from the training data on the test data, and that eliminates the chance of any data leak. Again, we are going to create a data frame out of it. So this thing is completely optional. If you don't want to use it, don't use it. So data is this, and columns will be ct dot get feature names out. Done. Let's see how it looks. The first few columns, first 5 columns in fact. So see, it has transformed the test data as well without computing any kind of statistics on this test data. So what it had learned from the training phase, it has applied that knowledge over here. So it eliminates the data leak problem. Now, once I have that, I'm going to use my model. So what is the name of my model? KNC underscore model. That's the name. So I'm going to use, say, KNC underscore model dot predict, and I'm going to supply my XTS transform. Okay. Once I'm going to say predict the values, then I'm going to store those values somewhere. So let's say y predicted value by my KNC model. Okay, so let's store it here, and now I'm going to measure the model performance. How I'm going to do that? I'm going to use these classes from sklearn dot matrix for accuracy score, precision score, and recall score. Okay, I'm using these three parameters, these three metrics. There are many others like F1 score, like ROC curve, things like that. I'm not going to show all of them. Just these three basics are there. I'm just going to use them to see how my model is doing. Okay, now print accuracy score, and here I'm going to supply two values. One is the y test value, another one is the y predicted value, KNC, the predicted value. Okay, precision score, YPR, KNC, print recall score, YTS, and Y predicted value underscore KNC. Okay, and it's going to give you a value error for your precision score because it is a multi-class classification and you should use uh, the averaging effect. So since it's the multi-class classification problem, should use this average parameter not as binary, which is the default label, but any other value like micro. So micro averages, macro averages, weighted averages, samples, etc. I'm just going to use the weighted average. Okay, so average, weighted, and here also, yes, here also weighted. Okay, now as we can see, all these values are 1. All these values are 1. So our model has done exceptionally well. It has predicted perfectly on the test data, not the training set data, on the test data. So it is not overfitting. Okay. Finally, I'm going to uh, read the sample data. So say sample df pd dot read csv. So fitness underscore sample dot csv. That's the name of the file. Sample underscore df. This is my sample data, and I'm going to transform these values. Okay, so let's say sample x, that's going to be my sample df dot drop exercise recommendation plan, this one, axis equals to 1, done. And the same transformation, ct equals ct dot transform only sample underscore x. I'm not going to create a data frame out of it, just going to have my data as numbers, numpy array. So sample x equals to this, transform it, and then tell my model to fit it, predict it. So KNC underscore model dot predict sample underscore x, and Nothing. Okay, so say sample predicted. Okay, so that's my prediction. Okay, and just ignore this warning. It is saying this because I have trained my model uh, using a data frame which had feature names, but here I'm supplying the only the numpy array which does not have any feature name. That is why it is showing the warning. Okay, if you don't want to see the warning, dd.data frame data equals to this one, columns equals to ct dot get feature names out. Okay, so now it's going to, okay, and to like so, and now we predict there's no warning. Now I'm going to say sample df. I'm going to create a new column predicted like so, and I'll say the values will be this sample predicted. Okay, now let's see sample underscore df how it looks. Okay, see, so actual value is 6, predicted value is 6, actual value is 7, predicted value is 7, so on and so forth. So it has performed exceptionally well to predict the class labels of this data set. So there you go, a small demonstration of how to use machine learning algorithm for predicting recommended exercise regime based on individuals' height, weight, BMI, gender, age, etc. Thank you all. Let's see you on the next video. Until then, bye bye.